Warning, the following video is intended for educational purposes only, as well as humor. Shadow XM1 apologizes for any confusion when trying to explain anything in this video scientifically, and will do his best to explain in layman's terms as much as possible. He is not responsible for seizures, fits of rage, confusion, brain scrambling, weeping, gnashing of teeth, hitting heads against a table or wall, or any other strange actions from viewers watching this video. Alright, hi guys, welcome to another presentation of Shadow XM1's Garage. In the world? Oh no. There we go. Welcome to another presentation of Shadow XM1's Garage. It's nice to see you all. This is probably going to be a more interesting version that I've uploaded. A more interesting video that I've uploaded, actually. This is going to be my video for my final paper for instrumentation. Now, our instructor gave us several options. Option 1 was a 3-page paper that will be in APA format, which includes a cover page and reference page, minimum of 5 pages. Okay. Option 2, use PowerPoint or some other source with a minimum of 10 slides. Okay. Tim can read, I promise. There will also be a cover page and a reference page. No. Option 3, a video of yourself summarizing what you read. This will be a minimum of 3 minutes long. So, I decided to go with option 3. Now, in case you're wondering, here's the manuscript we have to read. It's about 95 pages long. It's quite a long read for something for a final paper, and personally, I found it rather boring. So, anyway. But this is what I chose to do for my final paper, to make a video of what I've learned so far as understanding 4 to 20 milli loops, which is they're basically a measurement system for an industry and more. You'll find them used with PLC systems. Okay, yes, I know my wording, and I know which wording is supposed to go with what. I'm just a little tired, a little frustrated. I did this the first time, and I forgot to do a mic check, and you got video, but no sound. So, in honor of that, you might have noticed my t-shirt that I'm wearing. Well, that does rather well to go with what I've had to put up with so far. So, if any of you guys would like your own, Walmart originally had these, but unfortunately they don't carry them anymore. However, here you go. You can go to Amazon.com, key in this phrase, and there you go. There's your own dumbest way possible t-shirt if you're interested. It's in several sizes, extra large to 6XL, where you can tell the instructor you're annoyed with the most, or a fellow student of yours, more likely, who just doesn't get it. Just tell them, read what my t-shirt says. That's right. No, you're right. Let's do it the dumbest way possible because it's easier for you. I'm sure there are plenty of instructors out there who'd like to tell this to some of us students too. And in case you're wondering, yes, that's right, I'm in the way. So let me shrink. And you can see that properly. So there you go. Amazon.com. They have several sizes, from $14.49 to $21.99. All right. So without further ado, let's get on to this. All right. Let's shut that down. All right. Now, I've read some of this. well, I've read the most of it before nodding off and going to drowsing off into a deep sleep. But yeah, I found a way to go to sleep a little easier. Hey, but sorry, Amanda, my bad. Anyway, I decided to go with good old Google and find my questions and answers on there. Okay, the first one is, what are the limits to a 4 to 20 milliamp signal? All right, well, let's find out. All right, what are the limits of a 4 to 20 milliamp current signal? All right, a 4 to 20 milliamp current is commonly used to connect process signals to a controller in industrial applications. The principle of using a 4 to 20 milliamp loop is that a process range, in other words, of 0 to 100 degrees, is reflected by a corresponding 4 to 20 milliamp range for easy interfacing with connected equipment. There you go. So let's look at that a little bit closer, because there might be a little bit more. Yeah, this is freeelectronics.com in case you're interested. Let's see. And yes, okay. All right, well, that didn't exactly. All right, well, anyway, there's the limits right there. All right, when can it not be used? Well, let's see. When can it not be used? Well, first of all, let's look at www.predig.com on why. Well, no, that's a 0 milliamp signal. I'm sorry. Let's go with support.rhetorics.com and go and look at what can go wrong with the 4 to 20 milliamp loops. All right, many factors can lead to a malfunctioning 4 to 20 milliamp loop. The problem can be caused by a poor selection of power, wiring, or loop devices. In the event that the loop does not appear to work properly, it is recommended that you first check the power and wiring. In other words, it's time to put your maintenance specifications and expertise to good use. Multiple loops must be installed if we want to monitor all three of these channels available that we're using. So we're using 3 channels right here. So multiple loops must be installed if you want to get it right or accurate. Running so much wire could lead to problems with ground loops if independent loops are not properly isolated, or there is a bad wiring connections. There you go. There's what can go wrong. All right. Symptoms. Remember, rheonic sensors provide 3 non-isolated analog outputs, because we're going to describe what could happen with bad wiring, improperly earthing, and bring out possible solutions for these issues by adding 4 to 20 milliamp isolators. We have 3.5 MA that can be read as error signal. All right. Okay, what can go wrong? Unpredictable 4 to 20 milliamp signal fluctuations, which are a sign that something is interfering with your current loop. This is likely the result of electrical noise or a ground loop. There you go. Variations in display signal. These signals may also experience an addition or subtraction by some value from one point in the loop to another. This is caused because bad scaling is in the instrument. Okay, shared commons using signal averaging. Problems with shared non-isolated commons will commonly average the processed signal, causing the same value to be registered on devices that should be receiving different process variables. In other words, be careful how you hook stuff up. All right, here's another one. Physical damage to the components. Overload, poorly wiring, and dimensioning the devices in the loop. Power supply voltage must always be at least as high as the worst case sum of all of the voltage drops in the loop. All right. So there's what could go wrong. I know that's not exactly the best answers of when it cannot be used, but there are some problems. But there's a good example of what happens when it can go with the advantages and disadvantages, and what can go wrong. So, and if you're curious to want to read more, that was supportrheonics.com, right there. All right. Now, how is a 4 to 20 milliamp signal used in industry, and what are the components? All right. Okay. All right. Basically, well, actually, we kind of already answered that. Because once again, here you go. It's commonly used to connect process signals to a controller in industrial applications. The principle of using a 4 to 20 milliamp loop is that a process range 0 to 100 degrees is reflected by a corresponding 4 to 20 milliamp range for easy interfacing with connected equipment. And that basically means that it needs to reflect or measure up to the amount of degrees that you're using as far as measurement with your 4 to 20 milliamp loop. Because that's exactly what it basically is. It's a measurement sensor. Okay, and if you're wondering if that's right or not, here's the components needed for a 4 milliamp to 20 milliamp signal. First of all, you need a sensor. First, there needs to be some sort of sensor which measures a process variable. There you go. Next, you need a transmitter. This is second to none. Whatever the sensor is monitoring, there needs to be a way to convert its measurement into a current signal between 4 and 20 milliamps. Next, you need your power source. Next, you need your loop. And next, you need your receiver. Last but definitely not least. There you go. All right. Now, what is this? All right. Okay. Now we go. This will be used. Basically answered several questions. Says how will it be used in the future? Well, first of all, here's the advantages of a 4 to 20 milliamp. It can be run over long distances with minimal signal losses compared to voltage type signals. A varying current loop can load impedance or supply voltage, will not significantly affect the signal as long as it does not exceed recommended component limits. Rugged signal with low electromagnetic susceptibility. It saves on cable wire because it only needs 2 wires to function. Live zero reading verifies sensor is electrically functional. All right, here's some disadvantages. High power consumption compared to other analog signal types. Elevated output. Okay, Tim can read, I promise. Elevated output at zero reading. Supply not isolated from output. Increasing circuit load resistance. This will reduce the supply voltage available to power the transmitter that is generating the 4 to 20 milliamp signal. You don't want that. All right. The future of 4 to 20 milliamps, okay? Looking ahead, the future continues to look bright for the 4 to 20 milliamp signal transmission standard in industrial environments. Its lossless nature, lower sensitivity to induced noise, its live zero offset, fail-safe operation, and easy scalability contribute to its longevity. Plus, its adaptability to many different wire conductors and connectors, and its relative immunity to poor quality connections, and all contribute to its popularity. And because it is so widely supported by thousands of compatible devices, including wireless transducers, it would be difficult to unseat it as the leading analog transmission standard for industrial I/O. Likewise, modern variations of 4 to 20 milliamps, such as Heart 1, continue to drive support for the standard. So, in other words, how will it be used in the future? There's a perfect example. It already looks bright for the sensor itself because it's used in so many different types of equipment. So how will it be used in the future? Probably on new types of equipment, and probably on new types of equipment in both industry and electrical, as well as several others. So you never know. Heck, you never know. When we finally get out into space, it might be a new type of Geiger counter measurement, or a radiation measurement, or a spatial static electric measurement device. You never know. So, all right. Discuss the accuracy of a 4 to 20 milliamp signal. Okay. Well, that's basically, all right, the accuracy. Advantages, we've already covered that. High accuracy 4 to 20 milliamp current loop transmitter. All right, well, there you go. It has a high accuracy. This reference design shows how to develop a high performance, high voltage 2 or 3 wire 4 or 20 milliamp current loop transmitter suitable for industrial process control and smart sensors, error analysis, and over temperature characterization data, as well as hardware design and software are provided. So yeah, see, this shows you even how to make your own. If you're starting your own industry business or industrial business or automated business or whatever, here you go. If you have trouble trying to buy one already assembled, you can get the parts from DigiKey, Jameco, Mauser Electronics, SparkFun, wherever you want to go, and voila, there you go. There's your schematic for your own 4 to 20 milliamp loop transmitter. Right. So yeah, it has a high. Yeah, and this explains how it's a high frequency. High frequency, where basically it's done with the different types of components. Yeah, the U5 OP amp and Q3 buffer and figure 2 are sensing the virtual ground, continuously maintaining the common point for the smart sensor and keeping it at the constant voltage of the U4 output. The U5 OP amp, which, trust me, you guys who are going into digital and things like that later on, you'll see more of that. Or if you've already been in that, you know what I'm talking about. Must be capable of accepting a maximum supply voltage of 12 volts with a PRC R load sense resistor value up to 250 ohms. And there you go. This would be a good, now that I think about it, this would be a good project for instrumentation. Find the components you need, and build your own high accuracy 4 to 20 milliamp current loop transmitter. There you go. And see if it works, and see if you got it right, see if it works all right. You can test it on some of the industry. You can hook it up to the PLCs and test it and see if it's going to work all right. That would have been interesting. Even if you wanted to wait and use that for like more advanced classes, that would still be a good project to do right there. All right. All right. This is. All right. Compared to other analog signals used today. All right. Okay. Why a 4 to 20 mA current signal is used instead of a voltage signal. The electrical signals can be transmitted to two different ways: current signal and voltage signal. The voltage signal, when transmitted over a long distance, it causes a voltage drop in the wires. There might be a large voltage difference between the sending end and receiving end, and this leads to measurement errors as our process variable reading present in the voltage form. Okay, thus the voltage signal is generally not used because of more error in measurement. Current signal, on the other hand, the current signal does not get affected with voltage drop in the loop wires. The measuring accuracy of the current signal transmission is far better than voltage transmission signal. The transmitter manufactured for automation purposes can output from 0 to 20 or 4 to 20 in the signal. The 4 to 20 mA signal is preferred over a 0 to 20 mA signal because the broken wire can be easily detected with use of a 4 to 20 mA signal. Probably means is because the latter is probably more sensitive. If current observed in 0 and a 4 to 20 milliamp transmitter, the transmitter will output an error signal. The current signal can be transmitted without error to a distance of 1,000 meters. Wow! That's a long way, guys. That's a long way. Why a 4020 mA current signal? The transmitter is generally loop powered with 24 volt supply. The transmitter with this arrangement is called a 2-wire transmitter. The process signal can be measured by connecting an ampere meter in series with the 24 volt supply source. See, you can even measure the process signal via amp meter. The response of current signal is more linear than the response of voltage signal, and therefore current signal is preferred over voltage signal. All right. Well, there you go. All right. There we go. Here's an example right here of it working. It is desired that the signal must be reproduced at the control system and exactly what was produced at the transmitter end so that both sides read and display the same values. In other words, this side right here needs to measure this the same as this side over here. The signal should not interfere with the external electromagnetic interference or electrostatic interference. If these external signals superimpose on the measuring signal, it can cause substantial error in the measurement. So yeah, there you go. You want to make sure it's connected up properly. Right. Let's look a little bit more on that. How is a 420 compared to other analog signals used today? Okay. Here we go. Control.com. Why is a 4? Oh, wonderful. Well, thank you so much, Control.com. I don't want eBay. What analog signal Yeah, a 10-volt signal is susceptible to voltage drops caused by wire resistance, especially over long cable runs. A 4 to 20 milliamp signal, on the other hand, offers increased immunity to both electrical interference and signal loss over long cable runs. And most newer industrial controllers will accept current signals. So there you go. Let's see. And that was from automationinsights.blog. Okay. Now let's see. I think that's basically, yeah. Yeah. All right. Moving on. How is HART communication, or HART communication, how HART communication is used with 4 to 20 MA signals? Okay. Well, let's find out. Okay. The HART protocol provides two simultaneous communication channels: the 4 to 20 MA analog signal and a digital signal. Okay, the 4 to 20 MA signal communicates the primary measured value. In the case of a field instrument, using the 4 to 20 MA current loop, the fastest and most reliable industry standard. There you go. The HART protocol uses the 4 to 20 milliamp analog signal because, let's see, because it's the fastest and most reliable industry standard, and it's mostly used primarily out in the field. And from what this reads, yeah, the 4 to 20 MA analog signal reads better than any other. So yeah. All right. Let's see. Yeah, two modes of communication in a HART. Now, the two main operational modes of HART instruments: point to point, analog to digital mode, and multi drop mode. All right. And that's basically already told you how HART communication is used with the 4 to 20 MA signals. So, there you go. I hope that answered all the questions for the final paper. I hope that you enjoy watching this video. And like I said before, if you want your own Know You're Right, Let's Do It the Dumbest Way Possible because it's easy for you t-shirts, there you go. Go to Amazon.com, key in this text, and it'll take you straight there. Have several different sizes from X large to 6XL. And there you go. All right, guys. To those students watching, I hope this was educational. To my instructor, Mrs. Cullum, I hope this was accurate enough because this is what I chose to do. All right, guys, that's going to be all. I will post this up on Shadow XM1's Garage if you want to watch it. I will be posting some more stuff on Shadow XM1's Garage over the Christmas holidays. I hope to see you there. And as usual, I hope, like I said before, I hope this presentation was educational, entertaining, and amusing as well at times. I hope my instructor approves this. I hope you fellow students have gotten something out of this. All right, that'll be all. I'll go ahead and submit this to YouTube on my, like I said, my Shadow XM1's Garage channel. And also, I'll submit a link to this via a PDF file for you to get. All right. as far as my college courses go. All right, guys, that's going to be all for right now. I'm going to stop and see if I actually, yeah, there's the microphone. So I am recording audio. So I'm going to stop and upload this. And all those who I've seen in my associate's course, hope to see you again when I do my bachelor's. If not, good luck finding a job. I think we're all going to need some luck doing that. Hopefully not too much. But hope to see you then. Until then, you guys stay safe. You guys stay awesome.